Hello, and welcome back to another IB Math Speedrun with me, Vince. So today we're going to be completing chapter 5.2, which is all about descriptive statistics. So let's jump right in. So there are two main things you need to know. Assuming you've got your data and you're ready to analyze it, there are two main things you want to analyze. The first one is the measure of central tendency. If this is your data, where is the middle? What has the most data? That is a measure of central tendency. And the second one is the measure of, spread or dispersion. And so that's how far are the values from each other. So central tendency is where is the center. Dispersion is how far are the values. So to measure the central tendency, which you might, it sounds very complicated, but you might know it more commonly as the average, of the numbers. And so there are three ways to do this. The first one is the mean, or the arithmetic mean, technically. And so this is, the quotient of the sum of all the data values in the population. It's the, if you can express it mathematically, it's equal to x with a line over it. We use this to show the arithmetic mean of a sample, and this is from I is 1 to k of f1 xi, fi xi, over n, more or less. So this is the sum of the set of data, and n is the number of values in the data set. So this is arithmetic mean. I'm sure you've all done this before. If it's a sample, we express arithmetic mean as the x with a line over it. However, if it's the whole population, the mean of the whole population, we use the symbol mu, the Greek character mu, for the mean of the whole set of data. So next is the median. And the median is the value in the middle position when the data is arranged in order of size. If you have 3, 4, 5, 6, 7, then the median is 5. If you have an even number of terms, then that means, of course, there is no middle term, so you take the average of the two middle terms, or the mean of the two middle terms. So you take this 4 and 5 and get the mean, which is 4.5. Finally, the mode is the data that is most occurrent in the data set. So this may not seem mathematical, the thing that appears the most isn't necessarily the center, but this is extremely useful when we are dealing with qualitative data or discrete data, for where it's hard to get a mean or a median. Say, what is your favorite color? How would we get the average person's favorite color? We can't do it with the mean or the median, so we have to go with the mode, which is counting up which color the most people like. So those are the three measures of central tendency. Now we go on to the three measures of dispersion, and we'll talk about the first two only. So the first one we have is the range, and it's simply the largest value, the maximum value minus the minimum value encountered. This is the range. It's that simple. And so it's it's the simplest measure of the spread of the data. Next is the interquartile range, but to talk about the interquartile range, we need to talk about quartiles first. So a quartile is a quarter of the data. It's values that divide the data into quarters. So if you have your data all laid out, then what these quarters do is they allow you to divide the data, actually. You only need 3. So say you have 100 values, so your lowest 25 would go here, your next 25 would go here, your next 25 would go here, and your final 25 would go here, arranged in ascending order. And so the interquartile range is, we call this the first quartile. This is, of course, the median, and this is the third quartile. And the interquartile range is the difference between the first quartile and the third quartile. And so it's the measure of spread associated with the median. So This is often used to eliminate outliers because outliers usually lie past the first or after the third quartile, and so it can give a more accurate measure of the data spread. That's the interquartile range. So the last way to measure the last way to measure the measures of dispersion is called standard deviation, but we'll get to that later because that in itself is a topic. So yeah, we need to talk about how do we express the data. Once we've collected all the data, we want to have some way of expressing it. And the most common way to do that is by using a histogram. For continuous data. So a histogram has the the histogram has the frequency, or which is the number of times a certain data point has occurred on the y-axis, and on the x-axis we have the actual values. So yeah. So for example, this would be 10, this would be 20, this would be, say, 30, and if we have, say, 5 items that are between 0 and 10, continuous data, then we can draw this here. If we have 7 items between 10 and 20, we draw one bar here, and say 6 items between 20 and 30, we can draw a bar here. So, yeah. So the class width is the difference between the maximum and minimum values between each interval. So here we have a class width of 10 each time, since there's only a difference. The maximum difference between two values in the same class is 10. And yeah, so that's pretty much it. So if we are dealing with discrete data, however, we can edit our histogram a little to work with discrete data. So for discrete data, at least if it's numerical, if it's like non-numerical discrete data, then we would want to use some sort of like bar chart, like, okay, what's your favorite color? This is red, this is yellow, because these answers still have no correlation with each other technically. But if we're dealing with discrete numerical data, say the number of siblings, then we can still use a histogram and label it. So frequency, and we say number of siblings to 0, 1, 2, 3 over here. And there's a little bit of a technicality if it's discrete data, and it's that we would start the we would start the bar and end the bar at the maximum and minimum possible values, because we're treating the discrete data itself as a class. For example, if you have one child in the family, you would treat it as the range from 0.5 to 1.5, because those are the values for which you would round to 1. So if we were to draw that, there's a frequency of 4 families with 1 child, we would draw something like this. And then if there are 6 families with 2 children, we could draw it like here. And as you can see, the bars are still touching, indicating that there's a relationship between the numbers. So yeah, that's it. So let's jump into some questions. So the first question, I guess I'll just do the even ones because, yeah, they're harder. So the first question is, the length of 30 Swiss cheese plant leaves were measured, and the information grouped as shown. Measurements are taken to the nearest centimeter. So let me draw out the table that we're given. So normally we are given some form of frequency table. So we have the length and the frequency of the leaf. And so first we have 10 less than or equal to x is less than 15. And there are 3 leaves here. Next is 15 less than or equal to x is less than 20. So we have 8 leaves here. Next we have 20 is less than or equal to x is less than 25, and there are 12 here. And finally, we have 25 is less than or equal to x is less than 30. And we only have 7 leaves here. So the first question is this discrete or continuous data? I would say this is definitely continuous, but we are putting some form of boundaries in the form of how close we are measuring the data. So technically it is, I guess, discrete. So because we're rounding to the nearest centimeter. So if we were to draw a histogram, well, let's decide on our axes. Let's call this 10, 15, 20, 25, and 30. And our maximum y value is 12, and our minimum is 3. So 12, 6, 3, 9. So between 10 and 15, which actually, the thing is, since we're measuring to the nearest centimeter, we need to adjust the scale a little, because this is discrete data. So we actually need to include 9.5 in the measurement of 10. So 10, 15, 20, 25, and 30. Hold on. No, wait, sorry. Having a little brain fart. I think this is continuous, in fact. Yeah, it's probably continuous, honestly. So, where are we? Yeah, it is continuous. So, let's ignore what I said. So from 10 to 15, we have a frequency of 3. 15 to 20, we have a frequency of 8. So I'll put that on there. From 20 to 25, we have a frequency of around 12. And from 25 to 30, we have a frequency of 7. So this would be what our histogram looks like. Okay, let's move on to the final question. And the final question saying that we have a histogram here, 0, 30, 60, 0, 1, 2, 3, 4, 5. So let me just quickly sketch out what the histogram looks like. And so we're being asked whether it's displaying discrete or continuous data and suggest what it might be displaying. So is this discrete or continuous? Well, we can tell that this is actually continuous data, since we have we are not extending over to 0.5, because if it was discrete data, it would be centered around these points over here. So since we have continuous data, we have a continuous bar chart, and as to what it could be displaying, I'm not sure. Like, we can say anything. Say maybe the number of people living in a house. This would be an appropriate answer. So yeah, that was pretty much it for the speedrun. It was pretty short, but we went over quite a few concepts that you might need to know, and I hope to see you in the next one.